talk a little bit about robot safety. So we have, again, this is a list you should have already seen. A lot of these you've probably heard of. So for national standards, you have ANSI. Now, that stands for the American National Standards Institute, if I remember right. So, and they do have a full rule book that has been, then you have the Canadian standards. You have international standards, so you have ISO. Basically what all of this says and all of this is based on is what can you do and how can you install and how can it work when it comes to the robots. Okay. So RI 15.06 lists about the safety requirements, provides safety requirements for industrial robot manufacture, remanufacture, and rebuild, and the robot system integration installation. So basically what you're trying to do is assess and then build the system within these particular guidelines. Does that make sense? So we have robot manufacturers, we have the robot system and integration. Y'all can see this all right? Yeah. So part 2 is all about the system and integration. Yeah. All right, so the industrial robot. We've talked about this before. What makes up an industrial robot? What are the biggest mentioned ones across all definitions? Automatically controlled. That's one. What's another one? Reprogrammable. And multi-purpose. Okay. Reprogrammable, multi-purpose, automatically controlled. Those are the three main things that you need to know about the definition for any robot that's an industrial sort. So automatically controlled, reprogrammable, multi-purpose manipulator, programmable on 3 or more axes, which may either be fixed in place or mobile for use in industrial automation applications. The 3 that are the big ones here are these 2 right there. Automatically controlled, reprogrammable, multi-purpose. Okay. So what we call the robot's work area is the workspace. So this is the 3-dimensional volume of encompassing the movements of all robot parts through their axes. It's previously called the work envelope, but workspace is a little easier to understand. Why? Because we all like our space. We all like to have our little bubble we can put stuff in, right? And then when we need that thing, we can just kind of reach over and grab it without having to get up, walk across the room to pick it up, right? Because can a robot get up and walk across the room to go pick up a part? Not really. Unless it's on a track or on one of the glorified Roombas, it's a ground robot. And it is a, because what those do is they move in 2 dimensions. And if you put something on them, all of a sudden they can get more dimensions. So most of the time, robots cannot just get up, walk over, and pick up what they need to pick up. So we have to make sure that everything that they need to perform their task is where? Within easy reach, right? Just like if you're working at a workbench at home and you're trying to put something together. You want to keep it within easy reach. Or another way to think about it is, how many of y'all wrap presents for Christmas? Or whatever holidays or birthdays, y'all know what I'm talking about? Whenever you're doing that, what do you want to do? You want to have your scissors, your tape, and the paper all in one place so you don't have to do what? I want to have to get up, walk back to the attic, pick up this, come back. Now what I want is to put everything in my workspace so I can assemble this as fast as possible, right? Whether you're bagging and tagging it or if you're actually wrapping it, you got to have everything you need within easy reach. Same thing for robots. If it's in easy reach, it can do its job. So you have the maximum space. This is the volume of space encompassing the maximum design movements of all robot parts, including the end effector, workpieces, and attachments. So anything that the robot can get to is part of this maximum space. Okay? Restricted space, this is the portion of the maximum space to which a robot is restricted by limiting devices. Okay? So one of the things we do to limit robots is one of 2 things. One, we can limit them by putting them in a cage because they can't get out of those, right? Another thing we actually do, and this is kind of interesting for most people, but you have the ability to set, using the software of the robot, you have the ability to set software boundaries. You cannot exceed this point. You tell it that electronically, and it just sits there and goes, okay, I can't exceed that point. You know, there's only so far I can reach. Oops. That kind of thing. So that is what all that's about. Restricted space is, we have the whole room we could play in, but we are sitting at the desk, and that is the restricted space we have, right? Can I get up and walk around and do other things? Yeah. But I'll be outside my boundary. All right. Everybody good? So operating space. So this is the portion of the restricted space that's actually used while the robot is performing its task. Okay, so operating space is the immediate area around the robot itself where it's doing the task it's been set to do. Then you have the safeguarded space. This is the perimeter defined by the perimeter. Now again, we are kind of shifting things these days since we have the collaborative robots. We no longer put them behind a barrier. But at the same time, we do put in limits so that they cannot physically contact a human if the human is in its own, as long as the how do I say this? So the safeguard space is where you're going to have to go for a lot of things. So that's the perimeter devices. So one of the things you have to have on every teach pendant, or anytime you're walking into the robot cell, you have to have a three-way dead man switch, or three position. What that means is that if that robot all of a sudden starts swinging around towards you, what's going to happen? You're going to clinch up, and it's going to make the robot do an emergency stop. Okay? That is what this is for. And that's why whenever you're programming it, you have to have that little button pushed in to that middle position, right? In order to engage the robot. That's because once upon a time, they thought that people, when they're scared, they do what? They thought they dropped it. You know, just release your hand and it stops. However, most of us, when we get scared, what do? Huh? What now? Not really. Most of the time, whenever you're scared and fight or flight kicks in, you tend to tense up. So that's why you have the third position, the fully pressed in position. Does that make sense? So you have the three position dead man switch, which is required on all robots. It's a full on requirement for the teach pendant. So safety regarding stopping circuits. So we have a couple of different ways to stop a robot. We have the emergency stop, which would be done either with the dead man switch or hitting the giant red button. And we have a regular stop. So emergency stop, think slamming your brakes on so you can stop immediately because you're about to hit something. Versus a regular stop or safety stop, which is just going to come to its natural end, just like you press on a brake pedal very gently and just come to a gentle stop. That's what you actually want to do. So one of the things we have to do when it comes to safety equipment is create redundancy. Why? Why is redundancy a good thing? First one fails, you want a backup. That is absolutely true. You want any way to stop the robot to be control reliable, because if it's not, and one component fails to trigger, you're done. Because by the time that you get that robot to stop from that one circuit, something bad has happened. Because let's face it, how many times are you going to stop and press the E-stop? Unless you're maintenance and working on it. But the only reason that you do that is because something has already gone horribly wrong, right? So how do you make sure that it does not, how do you make sure that the way to stop the robot will stop the robot? You build in control reliable circuits. You make it to where they have more than one way to turn the robot off or make it stop doing what it's doing. Okay? So if a single component fails, it should not prevent the stopping action of the robot. They are hardware based. Now, why hardware? Y'all know what I mean by hardware, yeah? It means actual physical everything, right? We want something physical that has the ability to stop the robot before it goes total rogue and destroys its whole workspace. So what we do is we do create it through hardware, because if you did it through software, what might happen? Do I know? You could get a malfunction. I mean, that's probably the worst thing that could happen if you're doing it through software, would be Sometimes it don't work as well as what you think it will. So then all of a sudden you're in a hard place. If you think about it, how often does your phone glitch? Or your computer glitch? That's why we don't rely on software to do it. We rely on hardware because hardware is more reliable. So when a fault occurs, the safety function is performed and a safe state shall be maintained until the fault is corrected. Basically, if something goes wrong, the safety will make sure that it stops and will not start up again until the fault is cleared. What it means by fault is, oh no, something happened and I'm kind of freaking out. Now we need to lock down everything and it won't start back up again until you clear the fault and make sure everything's running right before you can resume use of the robot. All right, so one of the biggest things is about safety. So how many of you ever wear your safety hat? You know what I'm talking about? Everybody's got their own hats that they wear in life, right? So what you really have to do when it comes to safety, especially in working environments, is you have to wear that hat all the time. You have to wear your safety hat. Why? Because if you don't, that's when accidents occur. Most accidents, by the nature of an accident, most accidents are preventable. You can stop them before they ever happen. But a lot of the times it's what? People not paying attention. Or, they're not wearing their safety hat that day, so they sit there and just go, oh, this looks safe. No, you might want to look again. It says don't do that. So one of the things you need to be doing is be acquainted with robotic safety. So don't get in the cage with them. Watch out for pinch points, things like that. Understand safety standards, because that is going to be both the international safety standards as well as the safety standards of wherever you're working at the time. So you need to recognize the importance of safety reliability. In other words, make sure that you have your redundancies packed in. Does that make sense? Everybody knows what a redundancy is, right? Yeah? Be familiar with the human factor issue. So what would be a human factor issue, do you think? Hmm? You need to make sure everybody knows how to work with the robot, or at least know well enough, better than to get in the cage with it. It's kind of like you don't want to get in the cage with a prize MMA fighter, right? Because what's he going to do? He's going to put you on the ground. Robot's the same way. If you get in the cage with it, more than likely you're going to get put on the ground. And not in a good way. So, what we have to do with human factor issues, this is why you have warnings and cautions on everything, especially these days. Because you're trying to make sure the human factor issue, where people sit there and go, oh, this might be a good idea to do this. That's not what that was intended for. Don't do that. Oh, it's safe enough. Next thing you know, somebody gets hurt. So human factor issues are something you have to always consider, mainly because for a species that calls ourselves evolved, sometimes we do some really stupid things. So you need to be aware of safety sensors and monitoring. So what the interesting thing about a robot is, whenever it's perched, like any of these, most of the time you have sensors attached somewhere and talking to whatever the robot is doing. What that means is that even when it's perched, it could very well still be active. And what is the problem with that? Something triggers that sensor while you're sitting there trying to program it, or if you're trying to do maintenance on it. Next thing you know, that robot's in motion. You did not even realize that you had forgotten your e-stop or your dead man switch, and now you're going to be hurt bad. So you have to watch out for those sensors and whatever else is monitoring the line, because it can cause a lot of damage, not just to the equipment, but to you or whoever's in the cage with it. You need to make sure you have the proper safeguarding. Training is probably the best way you can prevent any accident is through training. What do we mean by training? That's where you have to do the thing where you sit in a nice room with a computer screen in front of you or a PowerPoint in front of you where they talk to you about the safety of that job. Then we all sit there and go, can I just like sleep through this? Right? Because generally it's an orientation you've heard what you think is a million times, but they might have something that is very important. Why? Because if you've never been around a certain robot, or let's say a gantry crane, there are certain ways that you need to be trained in to make sure that you do not get yourself in a position to be injured. Does that make sense? All right. You need to make sure you have your safety guidelines outlined and be able to understand definitions of anything that's in those outlines. So safety method is a method and technique used for avoiding accidents, and this includes includes the usual considerations of man, machine, workstations, environment, and interface behavior, but also the software. In other words, everything has to be considered. You can't leave out any factors when you're dealing with trying to make something safe, so that whenever you install it, somebody doesn't get hurt the next day because something got overlooked. It sounds mother henish, somebody always trying to find a way to make sure that everything's not going to hurt something, but most places are trying really hard, especially these days, to not attract the attention of OSHA or anybody else that's going to look into the safety of your anything, and may or may not have a problem. So the three major differences between a robot versus conventional machinery. So you have speed of movement, predictability of movement, and hazard zones. So conventional machinery hazard zones may be difficult to recognize but they are fixed with time. What are we talking about here? Well, if you have, let's say, a stamping press or a casting press, you know what I'm talking about? We over time recognize and fix problems with it because we can look at it and go, oh, that's not going to work right. That's going to be a bad thing. We need to fix that now. We need to put more safeguarding. We need to put a line on the floor and tell the employees, don't cross here. We might need to install a light curtain to make sure somebody's not in the area when the machinery's in use. Things like that. Right? We tend to fix that with time because we're not having to reprogram it most of the time. Most of the time it's just doing its job, and we're trying to figure out a way to keep people from breaking a finger. So the main difference between conventional machinery and a robot is that a robot can be programmed and reprogrammed for different jobs, react to changes in the process, I don't like the term making decisions from a limited number of choices. What it tends to do isn't so much making a decision as it's triggered in such a way that the secondary program will be in use versus the first program. Okay? Because these things are not, they're not alive. They are machinery. They are a tool. It's not alive. It cannot make arbitrary decisions. Right? That's one of those things of people always want to try and act like these guys have a mind of their own. No, the only reason they look like they have a mind of their own is because we do what? We program it. We put it in. We make it seem lifelike because we are able to use sensors and such to make it look lifelike. If you remember what I was showing y'all on the video a few minutes ago of the robots dancing or doing what's called parkour. The robot seems like it knows what it's doing. But the fact of the matter is, it took hours and hours of programming to get a robot like that to do what it does. So it's not an intelligent being. What it is very clever programming that is able to take different situational data, put it that way, situational data, and put it towards keeping itself running. Okay. Safety engineering should be applied to robot safety, especially in the human factor aspect and systems safety approaches. Okay. So causes of accidents. When we talk about engineering deficiency, what would be an engineering deficiency? What's a good example of that? Yes. Lack of sensors or lack of the correct programming. So what you're talking about with that is also, how many of y'all ever heard of the bridge that collapsed just because it got stuck in the wind and started oscillating? Most of y'all probably don't know about that, but what happened was you had this bridge that was spanning a really nice big gap. And it was a suspension bridge, much like what you see with suspension bridges. It just kind of sits there. People get back and forth across it on car. Well, what the engineers did not account for was the fact that you had the wind that would blow so strongly through it that would actually cause it to what's called oscillate or move and bend in ways it shouldn't. And this bridge actually completely collapsed, became no more because of an engineering deficiency. What they did not take into account is what causes its downfall and causes the accident. Lack of proper procedures. In other words, if you do not have people trained or do not have procedures in place to make sure people are safe, that causes a lot of accidents. Think about it this way. If you have a janitor that's brand new on the job and he goes and mops a whole area but does not put down one of those wet floor signs, that would be lack of proper procedures, right? Why? Because they didn't put it down, but maybe it was not explained to them that that is a necessity, not a might need to put that down. It's a put this here whenever you do this because that prevents an accident. Inadequate programming is another cause of an accident because if your programming is not holding up for what it needs to, then it's going to cause issues elsewhere. So emergency stop switches must appear on the control panel and also be added to the pendant used in the teach mode where the operator or programmer may be moving the robot's work in the robot's work envelope or workspace. Okay. So not only does it appear on that teach pennant, but it also appears on the controller. Why? Because that just makes for another layer of safety. You know, if you have somebody outside and they notice that you are unconscious on the inside of this cage while the robot is running, then you want somebody to be able to stop it. But you have the pendant in hand, they'll have to go to the controller to make it stop, right? So we have several levels of safety. We have the outermost level, that's a level 1. That is as safe as you can be because you are nowhere near the hazards that are inside the cage, right? Most of the time, if you put a cage around a robot, is somebody going to climb that? Probably not. That's one of the biggest ways we use to keep people out of there is just put up a fence line around it and tell people no entrance, authorized personnel only. You have the level 2. That's where you're going to have auxiliary sensors. This can be found as a safety pressure mat and or sensors. One of the things you might have at the level 1 going to level 2 side is what's called a door interlock. And what a door interlock does is what? You open that door, what does the robot do? It's going to stop immediately. Why? Because we want it to stop immediately. If somebody that is going into the cell while the robot is still running, we don't want that. So right here is where you will generally find a door interlock. Safety pressure mats and or sensors are generally not incorporated in a lot of robots. Why? Because we figure once we cage them off and we lock it down and tell people no unauthorized personnel, everybody should be in compliance with no unauthorized personnel. If you don't know what you're doing, don't be in here, don't do anything with this. Stay out, right? That is the major thing. We don't want them in there, so they need to stay out. So we don't often put those in there, but it is an option. You have what's called light curtains. Yes, those can be on the inside where you're dealing with the robot. It also can be out here just to make sure that nobody's trying to approach anything. Okay. And if you are into the level 3, so you're doing maintenance of some sort directly on the robot, that robot does not even need to be on or in any kind of action. If it is, it's going to be because you have that teach pendant on hand and ready to press the e-stop or the dead man switch. So safety is an important consideration when installing, programming, operating, and maintaining robots. Okay? It's considered as a judgment of the acceptability of danger, where danger is the combination of hazard and risk. So what that should mean to you, safety, most of the time if you are practicing unsafe behavior, that's all on you. That's because mentally you have had to look at what is the risk versus reward of something, and you've decided to take risk instead of playing it safe. So hazards is defined as an injury producer, so barking your shin on something or tripping over something, that's a hazard. The actual it becomes an incident when somebody actually trips and falls. Let's put it that way. You have something like a giant bump in a carpet, or you have power cords that are lining everywhere, right? Eventually somebody's going to trip because those are a hazard, but they will become a incident whenever somebody trips and falls on their face. So now the statistics of this have said that there's only 61 total injuries and fatalities in the last 25 years that robots have been run. Only 61. That's actually a really good number if you consider how many people are injured on the job each year. That's like 2 people a year, maybe getting on towards 3 some years, that are injured because of a robot. That's not bad odds. That's about like getting hit by lightning. You have that much of a chance, if not less, of getting, or if not more, of getting hit by lightning. So the causes of employee injury in robotic environments include parts of the body being caught in pinch points. That would be where, if it says don't put your fingers there, they generally have got warnings on most robots. Pinch point. Don't put your fingers there if you do not need to. Be aware that that is a pinch point. Being struck by a part or robot. Yeah, that happens quite frequently. Falling from the equipment or structure. In other words, if you're working on something, you might want to make sure both feet are still on terra firma. So slipping or tripping on walking or working surfaces. If you're a klutz like me, sometimes this is inevitable. Exposure to dangerous levels of heat or electricity and excessive physical strain. Now, one of the most common things that happens in most industry, or in most jobs period, is what? Not so much slipping and falling. A lot of it is from physical strain. What is the so-called maximum amount that somebody is supposed to lift without aid? Somewhere between 50 and 80 pounds. What's going to happen to your body if your boss tells you to pick that up on your own? You very well could strain your back, strain your knees. All sorts of things can happen with that. That's called excessive physical strain. This happens all day, every day. It does not take much. Sometimes it can take just grabbing a box and trying to move it. If you don't move the right way, you will hurt yourself. It's not a matter of if, it's a matter of when. That's why they always tell you lift with your knees, not your back, because your knees can take more. Your back can't take anything at all. It is probably the weakest point on the human body. It takes very little to mess up your back. And once it's messed up, it's pretty much for life. Safety standards are... I can't talk today. Feeling like seashells by the seashore at this point. Safety standards are very important in the workplace. All professional associations have defined the following priorities. Eliminate the hazard through the machine design. Apply safeguarding technology, warnings and labels. Train and instruct your workers of all types. And prescribe personal protective equipment and devices. In other words, they need to provide you with PPE. They need to provide you with training. They need to make sure all the warnings and labels are where they need to be. All the safeguards are in place. And maybe even design it so that you can't hurt yourself, can't get your fingers where they need to be in danger. Right? So human factor issues. How many of you have ever heard of ergonomics? A couple of y'all. What are ergonomics? Exactly. So let's put it in perspective for y'all. I'm 5-zip, and if you put in an HMI, so most people are about 6 foot these days, right? So how many of you have ever seen an HMI? It's a human-machine interface, basically a computer that interfaces with a whole system. You know what I'm talking about, yeah? Most of the time, people don't think about this when they're installing things. And that's the fact that you have people like me who are short that will be doing the same jobs with the same machine as somebody that is 6 feet tall. So one of the first things I noticed when I walked on the job at one of the jobs we were making, I walked right up to an HMI, and guess what the screen was? The screen wasn't here at eye level, it was up here. At which point I'm sitting there going, did you think that through for people that are a little bit shorter? You might want to kind of split the difference. Think about that for a second. Somebody that's really, really short, we have to do the same work with the same equipment. We can't get a step stool every time we want to look and have to mess with that HMI. So, human factor issues or engineering is the study of human-machine interaction. So, machine or robot designed with poor organ. I cannot today. Designed with poor ergonomics will be uncomfortable and tiring to use, may even be dangerous. It goes back to, why do we want to automate things? Well, most of the time when we're automating something, it's to get rid of a safety issue, right? That's 99% of it. Is we want to get rid of safety issues. It's not because we're trying to replace workers. It's because this has become a real safety issue or an issue, period. So what do we have to do? We got to fix it. It can't stay that way forever, right? What's one of the most common ways to have an ergonomic? How many of y'all use those anti-fatigue mats? Especially somewhere like the kitchen. I know what I'm talking about, right? It's those thick cushion floor mats. You use them at work, you see them a lot. Basically what they're supposed to do is, because our body is not meant to stand on concrete for 8 hours a day, 5 days a week. Eventually it can affect the structure of your foot, it can affect your knees, it can affect your back. Believe it or not, it can hurt you. That's why these days you have those big thick mats that get put on spaces where you're going to be standing for long periods of time. Because what does it allow you to do? If you're standing on it, you're not standing directly on concrete, you're standing on something a little bit softer and that has give. It's kind of nice to have something like that. Because if you don't stand on something like that, your feet are killing you at the end of the day, yeah? And it's not just always your feet. Sometimes it's your knees, your hips, and your back. All together. It's not fun. So besides the size of the work envelope or workspace of the robot, many factors should be considered and investigated, such as the layout of control panels. Like I said, somebody's short. You don't want our control panel all the way up here, where every day, all day long, I'm having to reach up. Because why is that poor ergonomic design? Because eventually it's going to start tearing into my shoulders and my back. Right? Having to constantly reach up to mess with something and keep your hands overhead can cause a lot of problems in your shoulders and your neck. Teach pendant accuracy, personal training, barrier guards, safety devices, interlocks, and warnings. So we keep coming back to warnings. Why do we have to keep coming back to warnings? Because the last thing you want to do is give somebody an excuse, right? Last thing you want is, I didn't know. I didn't know that I wasn't supposed to put my hand in a buzz saw. I'm still missing my hand though, so can I go to workman's comp and have no hand for the rest of my life? It's true. It happens all the time. The reason we put warnings on things is to keep people from doing something. Or if they do it, it's by thereby acknowledging that it is their own fault. That actually goes back to a very popular word that is in today's society called liability, right? Last thing you want is a liability problem. So that's why you put warnings out there. It makes it to where you cannot, why is their warning label on coffee? If you drink it too fast or it spills on you, you knew it was hot. You cannot blame us. Yeah. Oh yeah, but it means it's less likely you're going to get anything more than a small settlement. Hmm? That's how most companies are handling the so-called liabilities these days. They give you a payoff and say, okay, let's just make this go away. It's cheaper to pay you off than have to go back and do all this other stuff. Because anytime you take something to court, the only person that wins are the lawyers. So in addition to human factor issues, you should evaluate uh, the conditions of a robot's workstations when the operator enters the workstations for maintenance, programming, and the like. So not only do you need to make sure the outside and everything you're doing on the outside of the robot is comfortable and easy to use, but if somebody has to get inside with it, you don't want stuff that's going to be all over the floor to trip somebody up. Last thing you want to do is go head first into one of these things, because guarantee you it's going to win. If you play headbutt with a robot wins hands down every time. Okay? All right, guys, let's take